Welcome to today's lesson on algebraic factoring and expanding expressions. We'll be looking at several examples to understand these important algebraic techniques. Let's start with our first example. We need to factor x squared plus 8x. When factoring, we're looking for common factors that can be pulled out from each term. In this expression, can you spot the common factor? That's right. Both x squared and 8x contain at least one factor of x. So we can rewrite this as x times x plus 8. Let's double check our work. When we expand x times x plus 8, we get x times x plus x times 8, which gives us x squared plus 8x. So our factorization is correct. Now, let's move to our second example. We need to factor 12y plus 18. To factor this expression, we need to find the greatest common factor, or GCF, of 12y and 18. What is the largest number that divides both 12 and 18 evenly? Let's find out. 12 can be written as 2 times 2 times 3, and 18 can be written as 2 times 3 times 3. Looking at these factors, we can see that 2 times 3, which is 6, is the greatest common factor of 12 and 18. So we can rewrite our expression as 6 times 2y plus 3. Let's verify. 6 times 2y is 12y, and 6 times 3 is 18. So 6 times 2y plus 3 equals 12y plus 18. Our factorization is correct. Let's continue with our third example. We need to factor 10x plus 20. Similar to the previous example, we need to find the greatest common factor of 10x and 20. 10 can be written as 2 times 5, and 20 can be written as 2 times 2 times 5. So the greatest common factor is 2 times 5, which is 10. This means we can rewrite our expression as 10 times x plus 2. Let's verify. 10 times x is 10x, and 10 times 2 is 20. So 10 times x plus 2 equals 10x plus 20. Our factorization is correct. Now, let's move on to a different type of example. Here, we need to simplify the expression 2 times x plus 7 minus x. To simplify this, we first need to expand the parentheses by distributing the coefficient 2. 2 times x is 2x, and 2 times 7 is 14. So 2 times x plus 7 equals 2x plus 14. Now we have 2x plus 14 minus x. Let's combine the like terms. 2x minus x equals x. So our simplified expression is x plus 14. For our final example, we need to expand the expression 6 times m minus 8. To expand this expression, we distribute the coefficient 6 to each term inside the parentheses. 6 times m equals 6m, and 6 times negative 8 equals negative 48. So our expanded expression is 6m minus 48. Let's summarize what we've learned today. When factoring, we look for the greatest common factor that can be pulled out from each term. When expanding, we distribute coefficients to each term inside parentheses. Our examples demonstrated. Factoring out a variable, like in x squared plus 8x equals x times x plus 8. Factoring out a number, like in 12y plus 18 equals 6 times 2y plus 3, expanding expressions by distributing coefficients. Combining like terms and algebraic expressions, these skills are fundamental in algebra and will be useful in solving equations, working with polynomials, and many other areas of mathematics. Thank you for watching this lesson on factoring and expanding algebraic expressions. Practice these techniques regularly to build your algebra skills. Remember, factoring and expanding are like two sides of the same coin. One operation undoes the other. Keep practicing, and you'll master these important skills in no time.